Hello, good evening. My name is Vishwadeep and I welcome you on Unacademy's Computer Science Channel for unlimited learning. So today in this particular session, I am going to talk about hardware implementation of cache mapping. So what is the hardware mapping or hardware implementation of mapping? The hardware implementation says that when CPU generates a main memory address, using that address, how CPU will search into the cache, and to search into the cache to say it's a hit or miss, how exactly or what kind of exactly hardwares are needed. So all these, if you have heard about that multiplexers are needed, comparators are needed, then how many, what size, and every single thing I'm going to explain today in the today's lecture. And my dear friends, I can tell you one thing: if you are struggling with understanding the topic, then definitely I can assure that after today's lecture you will be able to understand every single aspect of this hardware implementation. So stay tuned until the last minute of the lecture. All my friends who are watching this particular lecture for the first time, or if you are watching me for the first time, my name is Vishwadeep and this is a little bit profile about me. All India rank 19, ME from IISc, 13 years of experience in teaching, 9 years in GATE, and these are the courses I am taking: computer organization, architecture, and data structure, and some coding interview problems also I will be helping you. This is a complete profile. If you want, I have written the GATE multiple times, so many GATE ranks in my third year, final year, and after that two masters, double masters, another intake from BITS Pilani in data science, and a good experience of working too, and a good professional skills also. So what I have brought here for you guys is my passion to teach. Yes, I left my software job for the betterment of that community who wanted to have a good quality education, and here with the Unacademy we are providing you a really good quality education here. So my friends, my passion is to teach, your passion is to learn. Let's combine these two so that we can learn best. And if you want to learn even more, then you need to come on Unacademy, boss. You need to come on Unacademy. So what I want from your end is download the Unacademy app and then follow this profile, follow this particular profile. My name is Vishwadeep. Search my name, follow that profile, and you will be able to access unlimited content over there. So already I am having so many free special classes recorded in Unacademy platform, so you can access those. I have already taught pipelining over there, I have already taught cache mapping once again over there, I have already taught so many topics of data structures all there, I have taught so many basic plus complex problems on linked list also there. So you want, if you want, then you can get all those lectures for free. Other than that, my friends, if you want your preparation to be on the highest level, if you want that you should have a well structured, well organized, and most important part is more curated, more organized manner courses, then this is the place, Unacademy Plus. So come on to the Unacademy Plus. There you will be getting live classes, more interactive, hence you will be having so many doubts. All those doubts we will be clearing. So you will be having live classes, unlimited practice questions, daily practice problems we are giving you, so many doubt solution or doubt clearing sessions, structured schedule, structured lectures, and then test series, and every single thing is available under one subscription, that is Unacademy Plus subscription. But my friends, if you are from a college, which is not too great, and if you want a personal coach, ji haan, if you want a personal coach, if you want that somebody should be there to manage your day-to-day planning, day-to-day schedule, and if you want the expert guidance on very regular basis, then you can go for Unacademy's iconic subscription. Go for iconic subscription, your rank also will be iconic. And what, my friends, what you can do is you can take the subscription using the code VDEEP10 and you will be getting 10% card discount for either plus subscription or iconic subscription, whichever you choose. So my friends, if you are really seeking for somebody's guidance, if you are seeking for really well structured, well organized and more practice sessions for any kind of course, then this is the place, my friends. This is the place. An Academy Plus subscription you can take, and then definitely I can assure you from my end that you will never going to regret on this particular thing. And one more thing, my friends, tomorrow 8th of September we are going to launch a new batch. हम लोग एक नई बैच लॉन्च करने जा रहे हैं कल से, and this particular batch, look at this, the high profile educators, the very highly experienced educators we have in the team, and that particular team will complete all the courses of your GATE exam, and that too within the time limit, that too with the highest level of clarity. So if you are really interested to learn from the highest experienced, highly experienced educators with the highly organized manner, then my friends, Unacademy Plus is your way to go to achieve your dream rank, your dream IIT. Tomorrow, yes, 8th September, tomorrow. So today, if you will take subscription, tomorrow you will be able to join the new batch. New batch time is 9 a.m. onwards. And my friends, you are going to learn a lot in this particular batch. So if you are really interested, join. But what you can do is use the code VDEEP10. VDEEP10 is the code for the subscription, so that you can get a discount of 10%, plus you can get my personal guidance also, my team's support also, and so many other benefits you can get. Okay, so let's start the topic today. If you are new here, you will hear this particular word, these particular words again and again and again daily. If you are regular here, then my friend, you know what exactly you are going to hear from my end. Jaldi se bata do. Are you ready, my friend? Are you ready for learning or not? If you are ready, just type down in the comment box that you are ready, so that we can go further. जल्दी से बताएं दोस्तों कि आप लोग रेडी है या नहीं लर्निंग के लिए. I already told you this is the platform for unlimited learning. जी हाँ दोस्तों, लर्निंग आपको बहुत सारी मिलने वाली है, बहुत कुछ सीखने को मिलेगा. Okay, good evening, welcome everybody whoever watching this particular lecture. Like the lecture and subscribe the channel if you haven't till now, just because we are conducting so many live classes for GATE computer science on this channel. Okay, so if you are ready, type down. Okay, ready. Fine. So let's go further in the recap. Let's see what we have discussed till now. So I told you 3 types of mapping we have. One is direct mapping, another one is set associative mapping, and the last one is fully associative mapping. So my friends, आज आपको दोस्त बोला, बुरा तो नहीं लगा? ये ज्यादा अच्छा तो नहीं लग गया? Okay, welcome everybody, welcome, प्रणाम and नमस्कार, आदाब, सत श्री अकाल, सबका वेलकम है. चलिए, let's see. In the direct mapping, I told you one thing, that you are going to have 3 fields in the main memory का address format. Can you please name down quickly? जल्दी से नाम बताओ. What are the 3 parts? The tag and cache memory block number and byte offset, right? And then one more thing I told you कि कैश मेमोरी का ब्लॉक नंबर और लाइन नंबर आर सेम टू सेम चीजें होती हैं. These two are same to same thing. Line number और block number same to same. And other than that, one more thing I told you, अगर आपको याद होगा तो the middle part is named as or known as index part. If you remember that, right? And then other than that, if I will talk about this one, set associative mapping. For set associative mapping, can you please name down the three parts in which we divide the main memory का address? क्या है? जल्दी से टाइप करके बताओ, जल्दी से टाइप करके बताओ. Quickly. So you will be having here tag and middle field is set offset and right side is byte offset. Right, and one more thing I told you, the same thing again, the middle part is here known as index. तो अगर आपसे कोई पूछता है कि इंडेक्स फील्ड में कितनी बिट, तो आप पूछो सर पहले मैपिंग तो बताओ. मैपिंग बताया आपने, डायरेक्ट मैपिंग, सो यू कैन से as many as bits required for cache memory block numbering. If somebody says for set associative mapping, then as many as bits required for the set associativity, for the set offset. And somebody asks how many bits for index in the fully associative, क्या आंसर आएगा आपका? बताओ, बोलो. So for fully associative mapping, we divide the main memory का address into only two parts. What are the two parts? Tag and byte offset. In that case, मिडिल फील्ड में कुछ है क्या भैया? मिडिल फील्ड में कुछ है क्या? नहीं है. तो आप क्या कह सकते हैं कि in this fully associative mapping, the tag bits are whatever, index bits are how many? For fully associative mapping, index is equal to 0 bits. एकदम शून्य, nil बेटा, सन्नाटा. जी हाँ, 0. Okay, so remember this particular point, that in the fully associative mapping we have index bits 0, just because we don't require any kind of mapping at all. अगर आपको इतना याद है, I have given a quick recap so that you can remember. Now let's see how we check the hit or miss in the direct mapping. आपको शायद पहले का कभी याद हो, that's well and good. If you don't remember, then today I am going to repeat it again, how you are going to check hit or miss. So here we have the cache memory के blocks and here we have the tag. What happens? देखते हैं यहाँ पे. So when CPU generates main memory का address, then that address we divide into three parts: tag, block and byte. Now using this block field says कि this main memory का address can map to which address or which block in the cache memory. किस block पे map करेगा, ये कैसे पता चलेगा? ये block number बताएगा. अगर ये ब्लॉक नंबर बताता है, then we will go to that block. हम वहां जाएंगे, उस ब्लॉक पे गए और उस ब्लॉक पे जाके हमें क्या चेक करना है? हमें चेक करना है कि भैया टैग क्या है यहाँ पे. अरे भैया टैग क्या है? टैग. सो हम क्या करेंगे? इस टैग को एक्सट्रैक्ट करेंगे and then we will extract the tag from here and then we will take this particular tag and then we will compare these. Comparison result can tell us hit or miss. Hit क्या miss है? So if you remember this particular part, then this is the actual diagram which I brought for you in the proper manner. In the proper manner, आप देख सकते हैं main memory address is divided here into three parts and that particular three part will help us for the hit or miss checking. So based on this block, we are going to a specific block. Whatever the tag present over their block, that tag we are extracting and comparing with the CPU's requested tag. If it is matching, then hit; not matching, then miss. So here hit or miss will be declared. These are the cache memory ka blocks. If you are fine with this, जल्दी से बता दो इतना समझ में आया है आप लोगों को. If you are done with this, जल्दी से बता दो आपको समझ में आया है, नहीं आया है. अब बात करते हैं कि ये हार्डवेयर से इंप्लीमेंट कैसे होगा. अब है एक्चुअल चीज जो मैं आपको बताना चाहता था. This is the actual thing which I actually wanted to explain you कि how this hardware implementation is done, how this particular scenario which I explained you, how exactly using the hardwares it is implemented. So I am just taking a simple example. Number of blocks in cache are 4, which is 00 to 11, which means for cache memory ka block numbering, how many bits are required? How many bits are required? 2 bits. Plus block size 16 bytes, which is 2 power 4 bytes, hence byte offset will be of 2 bits or 4 bytes. 4 bits. Block size is 2 power 4 bytes, hence 4 bits will be required for byte offset. Main memory address is total 8 bits. Let's see and let's go further. So these are the 8 bits. ये है 8 bit. These are the 8 bits. These 8 bits are divided into byte offset 4 bits. Why? Just because 2 power 4 is the block size. 2 bits are in the block. Why? Just because this 4 number of blocks are there and remaining 2 bits for the tag. So what I am saying, if 4 blocks you have in the cache memory 00, 01, 10 and 11, this is the cache memory ka blocks. And the left side we have tags. What exactly the hardware should do? Hardware को क्या करना है? Based on this block, if this block says 00, among 8 bits, the middle these 2 bits says 00. What does it mean? इसका मतलब क्या है अगर यहाँ पे 00 आया है? The CPU's generated address maps to block number 00. So what I'll have to do is I'll have to extract this particular tag, corresponding tag of block 00 through this particular some kind of hardware, and I'll have to send it for comparison. मुझे वही tag extract करके लेके आना है जिस particular tag को compare करना है. So what will happen in that case? What will happen in that case? The simplest thing happen कि I'll have to use some kind of hardware from here, and that particular hardware can extract my tag bits. Which one? Based on this particular block. So I will have to use a mux from here. To extract the tag, I'll have to use the mux. अगर आप लोगों को मल्टीप्लेक्सर का वर्किंग पता है, well and good. If you don't know what is the multiplexer's working, then I can tell you multiplexer is a hardware which selects or which extracts one among multiple inputs, which extracts or forwards one among multiple inputs. So I am having multiplexer. In that I have given 4 inputs. Among these 4 inputs, which input I'll have to select? For that I will need select lines. तो ये black में जो दिख रहा है ना दोस्तों, ये है आपकी select lines. So if block number is 00, from this particular tag will be forwarded as output of mux. If these 2 bits are 01, then I'll have to forward tag of this 01 block from mux. तो mux कैसे काम करता है आपको basically अगर पता है, well and good. If not, then what I'm telling you is this, कि this particular multiplexer will select one of the tags based on the select lines, and select line is nothing but the block ka number. Okay, so if this much is fine, then let's go further and let's try to understand few more things. Now I am giving you one particular thing, one thing I am asking you, how many bits are there in the tag? कितनी bits है tag में? 2 bits, and there is a limitation of this mux. There is a limitation of this mux, and that limitation is I am having, that limitation is what? A mux, one multiplexer can forward only 1 bit of tag. ये जो tag है इसमें है 2 bits, but this one multiplexer can forward only 1 bit. So how many such multiplexers are needed to forward complete tag information of just 2 bits here in the example, but हमारे real example में 2 से ज़्यादा bit भी हो सकती है. We can have more tag bits, yes, sometimes 4, sometimes 18, sometimes 16, sometimes 15, 14. बहुत सारे क्वेश्चन आपने और मैंने सॉल्व किए. So tag bits if are 16, then such kind of 16 multiplexers are needed so that entire tag can be forwarded. If you could not understand, imagine करो एक घर में 15 लोग रह रहे हैं और मुझे 15 लोगों को अरेस्ट करना है. अब प्रॉब्लम ये है कि अगर मैं एक को अरेस्ट करने के लिए गया तो बचे हुए 14 लोग या तो मुझे मारेंगे या फिर भगा देंगे मुझे या फिर खुद भाग जाएंगे. तो मैंने क्या किया, मैं एक टीम लेके गया 15 लोगों की. आई वेंट देयर विद द टीम ऑफ 15 मेंबर्स सो दैट वन पर्सन कैन कैच वन फेलो फ्रॉम द हाउस. इट इज एग्जैक्टली सेम थिंग. दिस इज एग्जैक्टली सेम थिंग कि आई एम गोइंग टू कैच ऑल द टैग बिट्स. आई एम गोइंग टू फॉरवर्ड ऑल द टैग बिट्स हियर फॉर द कंपैरिजन. राइट नाउ इफ टैग बिट्स आर 2, then I will require 2 multiplexers so that one mux can forward 1 bit, another mux can forward another bit. Similarly, if I'll be having 16 bits in the tag field, then I will require 16 multiplexers so that all the 16 bits can be forwarded from this multiplexer of this tag. तो अगर आपसे कोई पूछता है कि how many multiplexers are needed, number of mux needed for टैग सिलेक्शन, टैग को सिलेक्ट करने के लिए कितने आपको मल्टीप्लेक्सर्स लगेंगे. सो इन जनरलाइज्ड केस आई कैन राइट इक्वल टू टैग बिट्स. जितनी बिट्स हैं टैग में उतना ही number of tags, number of mux you will require. Very simple, very simple, very simple. Now, ये mux का size तो बताओ. How many inputs we have in this mux? How many inputs we have in the mux? 4. You know why? Just because I'll have to select one of the tag among 4. और 4 ही tag क्यों थे? Just because we have 4 number of blocks in the cache memory. हाँ जी बाबूजी, हमारे पास कैश मेमोरी में सिर्फ 4 ही ब्लॉक हैं और 4 में से एक कोई टैग आगे सिलेक्ट करके भेजना था, इसलिए 4 इनपुट गए मल्टीप्लेक्सर में. इफ यू आर अंडरस्टैंडिंग दैट मच, देन आई विल हैव टू राइट व्हाट इज द साइज ऑफ मक्स. साइज ऑफ mux required for what? For tag selection. And that will be equal to what? कितने number of inputs हैं इस mux में? Number of inputs equal to 4 just because 4 blocks we have. Hence, I'll have to write here as number of blocks in cache is to 1. Number of blocks into the cache is to 1 is the mux size required for tag selection. अब बात करते हैं इसकी कि यहाँ पे जो कंपैरिजन होगा तो इसके लिए लगेगा एक कंपैरेटर. This hardware is called as comparator. What it is called as? Comparator. So can you tell me this comparator is used for what? To compare what? Tag. And what is the size of tag? As of now 2 bits. आपके एग्जाम्पल में कुछ और हो सकता है, किसी अलग प्रश्न में कुछ और हो सकता है. इन some other examples, in some other question, it can be anything. तो अगर ऐसा है, how many bits you are comparing? Tag bits. So the size of comparator will be equal to what? Equal to tag bit size. So right now if tag bit is 2, I will talk about this like this way, or I will call it like this way. 2 bit comparator required. 2 बिट क्यों? क्योंकि यहां से भी 2 बिट आ रहा है और यहां से भी 2 बिट आता है. So 2 bits are 2 inputs in the comparator. That's why a 2 bit comparator. Okay, remember this. याद रखें. तो एक और चीज यहाँ पे लिखेंगे हम, size of comparator. क्या बोला मैंने? जल्दी से टाइप करके बताओ. जल्दी से टाइप करके बताओ रे भैया. अरे भैया बोलता हूँ इसका मतलब ये नहीं कि दीदियां लोग आप नहीं लिखेंगे, लिखो। व्हाट इज द साइज ऑफ कंपैरेटर? What is the size of comparator? Size of comparator equal to tag bits. If tag bit is 8 bits, then 8 bit comparator required. If tag bits are 16 bit, then 16 bit comparator required. Remember this. So these kind of circuitry required to say if it's a hit or miss. तो यहाँ comparison से क्या मिलेगा? Result मिलेगा कि if comparison is true, then hit or else miss. So based on 1 or 0, I can say matching hit, not matching miss. Okay, that's great. That's great. सृष्टि, समीन, हीना, सुपर्ब, 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 सुपर्ब. चलिए अब बात करते हैं इस चीज की जो मैंने आपको बताया था कि instead of using one mux, I'll have to use multiple mux here. I'll have to use what? Multiple mux here. So I'm writing here multiple mux. गॉट इट। चलिए इस मक्स का साइज कितना था? 4:1। कैसे बोल दिया? 4 इनपुट्स हैं, 1 आउटपुट है, सिंपल। ग्रेट ग्रेट। अब बात करते हैं हिट लेटेंसी की। व्हाट इज द मीनिंग ऑफ लेटेंसी? लेटेंसी मींस एक्स्ट्रा टाइम रिक्वायर्ड फॉर समथिंग, सम टाइम रिक्वायर्ड फॉर समथिंग। मतलब कैश में जब एड्रेस आया उसके बाद कैश मेमोरी को कितना टाइम लगेगा हिट और मिस बताने के लिए? How much time required in the cache memory once the cache controller receives the address to say it's a hit or miss? That is called as hit latency time. अब आप खुद ही हार्डवेयर देख लो यार, आप खुद ही हार्डवेयर देख लो। First of all, using this block number, my multiplexers will select one of the tags from here and will forward those tags. So first of all, multiplexer delay will be required. Yes. If suppose I am saying 100 multiplexers, no, let's say 128 mux you are having, or let's say 16 mux you are having. Very simple. Let's say 16 mux you are having. Then should I require 16 times mux delay? ना रे, 16 times नहीं लगेगा क्योंकि सब पैरेलल में काम कर रहे हैं। ज्यादा mux लगाने का फायदा ये है ना कि सब पैरेलल में काम कर सके। So 111111 bits are forwarded from each mux parallelly. That's why if one multiplexer time is 1.6 nanosecond or let's say 2 nanosecond, then total 2 nanosecond required for all the mux क्योंकि सब पैरेलल में काम करेंगे। सिंपल सी बात है। चलिए okay, so find hit or miss time will be equal to, first of all, the multiplexer delay. Mux delay for tag selection. After that, what is required? After that, this comparison is required, and for comparison, I am having a hardware called as comparator. Hence, a comparator delay also required. अभी आपने मेरे से एक क्वेश्चन पूछा कि सर हिट लेटेंसी इतना है तो मिस लेटेंसी 1 माइनस दिस होगा क्या? अरे सर, हाथ जोड़ते हैं हम आपके। सिंपल सी बात है, हिट या मिस पता करना है, रेशियो नहीं पता करना है। हाँ जी, रेशियो नहीं पता करना है। थोड़ा दिमाग लगाएं, थोड़ा सा दिमाग लगाएं, इसमें बहुत ताकत होती है। जी हाँ, बहुत ताकत होती है। तो थोड़ा सा दिमाग लगाएं और सोचें कि ये क्या लिखा है मैंने यहाँ पे, बार बार क्या लिखा है मैंने। ये मक्स, from the mux and then comparator, I will be able to know कि it's a hit or miss. तो hit latency time or miss latency time is exactly same to same. I can say in that much amount of time कि it's a hit in the cache memory or miss in the cache memory. So if you call it as a hit latency or if you call it as a miss latency, दोनों बराबर ही हैं, exactly same to same हैं। ठीक है, if you are fine with this particular thing, let's go for the another one, set associative mapping. Okay, so for set associative mapping, the very first thing is we divide the main memory ka address into two parts or three parts. 3 parts or 2 parts? 3 parts. Tag, set offset, byte offset. Okay, now this set offset gives you what? A particular set number. एक सेट पे कितने ब्लॉक हैं? On one set you are having two blocks, one here and their respective tags are here and here. अब किस पे ये ब्लॉक हो सकता है? This main memory address can be present over here also. Then in that case I'll have to compare this tag also and this tag also. तो मुझे क्या करना पड़ेगा? I will have to take both the tags out of this particular tag directory and I'll have to compare it with this particular tag. I'll have to take this one also out of this and then I'll have to compare with this. So here I will be having two comparisons. You know why? I am just talking about two-way set associative mapping. If I have missed this, so I am talking about two-way set associative mapping. Srishti, no, you cannot say that. You cannot say that. Number of blocks in the cache memory can be different than the tag bits. Here it's the same, but it can be different. So I am talking about, मैं बात कर रहा हूँ आपसे यहाँ पे two-way set associative की. In the two-way set associative mapping, on each index जो set है, हर एक set पे आपके पास होते हैं दो block. If two different blocks you are having, then you have two different tags. Both the tags will be compared with the CPU's generated tag simultaneously. Yes, simultaneously. That's the hit or miss. So after this, from here, after this, what I'll have to do is I'll have to check it out that if any of these two comparison, this one or this one, any of these two comparison can be equal. If this say yes or this say yes, then there will be a hit, otherwise miss. शायद मैं आपके लिए डायग्राम लेके आया हूं. जी हाँ, आप देख सकते हैं. So if CPU generates a main memory address, suppose this is the set number 2, 3, 4 something. On that set we have two blocks. Here two blocks we have 1 and 2, and for those two blocks I am having two tags. तो दोनों टैग को कंपेयर करना पड़ेगा. दोनों टैग को कंपेयर करना पड़ेगा, इसके भी और इसके भी. So this particular CPU's generated tag will be compared with this one also and this one also, and based on that I will check if this say yes or this say yes, then there will be a hit or miss. So I'll have to check if any of these two says hit, then there will be a hit, otherwise miss. तो अगर आप लोगों को बेसिक चीज समझ में आई है तो जल्दी से टाइप कर दो भैया समझ में आया है कि नहीं, सो दैट वी कैन गो फर्दर एंड वी कैन अंडरस्टैंड मोर डिटेल कि अब ये दो टैग कैसे एक्सट्रैक्ट होंगे. ये देखिए दोस्तों, आई हैव टेकन अ वेरी सिंपल एग्जाम्पल. चलिए एग्जाम्पल का नाम मैंने अगर नहीं लिया है तो मैं एग्जाम्पल का नंबर बता देता हूँ. नंबर मीन्स फोन नंबर नहीं दे रहा रे. लड़के एक्साइटेड हो, सर एग्जाम्पल का नंबर मिलेगा. कौन है, लड़का है लड़की है? अरे एग्जाम्पल इज एग्जाम्पल, उदाहरण बोलते हैं इसे. Fine, okay, so look at this buddy, look at this. So in the example I have taken number of blocks in cache memory is equal to 8 and we have two-way set associative cache. देखिए दोस्तों, ऐसा है अगर टू वे सेट एसोसिएटिव कैश हो गया एंड 8 नंबर ऑफ ब्लॉक्स आर देयर, कैन यू टेल मी हाउ मेनी नंबर ऑफ सेट्स वी कैन हैव इन द कैश मेमोरी? जल्दी से बताओ हाउ मेनी नंबर ऑफ सेट्स इन द कैश मेमोरी इज इक्वल टू हाउ मेनी नंबर ऑफ सेट्स इज इक्वल टू 8 डिवाइड बाय 2. कैसे किया? नंबर ऑफ ब्लॉक्स डिवाइड बाय एसोसिएटिविटी से किया. 4. Number of sets is equal to 4. Okay, so based on these number of blocks is equal to 4, I will have 2 bits in the set associated. So it's set offset. This set offset will be of 2 bits. Yes. So if whatever the main memory address we have, that main memory ka address we will first divide into tag and set offset and byte offset. Based on this set, I'll be going to the different set. Abhi pehle ye, before we extract the tag or something I will explain you. एक छोटी सी बात मैं बताऊंगा आप लोगों को. This is one set number 0. On that set number 0 we have two blocks. मैं थोड़ा अलग अलग कलर लेके आया हूं so that you can understand कि which particular tag is which one. Set number 10 and set number 11. क्या मैंने अपनी खोपड़ियां उड़ा दी? नहीं उड़ाई, थोड़ी सी बच गई. Okay, so set number 0, 0, 0, 1, 1, 0 and 1, 1, 4 sets are there. On each set we are having two blocks, this one and this one. For this block we have this tag, this one, this tag. तो ये दो टैग अलग, ये दो टैग अलग, ये दो टैग अलग और ये दो टैग अलग. First of all, I am trying to extract only first tag of each set. मैं अभी सिर्फ और सिर्फ पहला टैग उठाने की कोशिश कर रहा हूँ. कोशिश में क्या होगा? कोशिश में ये देखिए क्या होगा. So set says suppose 0 0. अगर set बोलता है 0 0 तो I'll have to extract what? I'll have to extract these two tags. ये दोनों, एक ये और एक ये. दो टैग्स आपको वहां से एक्सट्रैक्ट करना है. सपोज आई एम टॉकिंग अबाउट ओनली फर्स्ट वन. सो फॉर दैट फर्स्ट वन, this set offset should be 0 0. ये first one is going to my multiplexer. अभी देखिए मैं डायरेक्टली आपको bunch of multiplexer दिखा रहा हूँ यहाँ पे. Directly I am showing you the bunch of multiplexer. Why? Just because this statement is still true, dear. This particular statement is still true कि one mux can forward only one bit of tag. If I am having multiple bits on the tag, then definitely I will require multiple multiplexers. ज़्यादा multiplexers की जरूरत पड़ेगी. ये ज्यादा मल्टीप्लेक्सर्स हैं मेरे पास, जी हाँ हैं. सो बेस्ड ऑन this particular set of set bits 2 0 0 or 0 1 or 1 0 or 1 1, I will forward first block का tag from this multiplexer into comparator. If you are fine with this, अभी और दूसरा वाला भी तो बचा है. I'll have to compare this tag also, right? So for that ये same setup, ये जो multiplexer और comparator का setup है, ये एक और लेना पड़ेगा जिस तरीके से ये. One more comparator and multiplexer का setup I'll have here. Yes. तो ये है आपके पास set number 0 0 and next one is set number 0 1 and next is set number 1 0 and this last one is set 1 1. और मैंने यहाँ पे ब्लू कलर दिखा के आपको ये बताया है कि हर एक सेट के दो टैग में से from each set two tags are there. One particular tag, first tags will be selected by another multiplexer का set and then two second tags will be selected from another set of multiplexers. So that अगर आप पूरा एक साथ देखोगे इसको तो कुछ ऐसा दिखेगा. This is the set number 0 0, set number 0 1, set number 1 0 and set number 1 1. आप देखिए, suppose set number is 1 0, so this mux will select what? 1 0. ये वाला first tag of 1 0 set and this particular set of mux will select second वाला. ये देखिए 1 0 के according this वाला. So this and these two tags will be selected, one from here, one from here. Comparison होगा और comparison में से अगर यहाँ true आया तो hit या फिर यहाँ true आया तो hit. So either of these two says hit means hit. And that's why I am having one OR gate. एक OR gate लगेगा. अब OR gate की functionality आपको पता होगी. You should have known that. If you know what is OR gate, that's superb. If you don't know, then OR gate is very simplest kind of or simple kind of gate. If any of the two inputs are true, then the result will be true. So here OR gate can say it's a hit or miss. And sometime in some implementation, this OR gate is implemented using 2:1 mux also. कभी कभी ये जो और गेट है ये 2:1 मक्स की हेल्प से भी इंप्लीमेंट हो सकता है, याद रख सकते हो। हाउ, एक बार ऑनलाइन पे डियर लिख के तो देखो, हाउ टू इंप्लीमेंट और गेट यूजिंग 2:1 मक्स, आपको बहुत आसानी से समझ में आ जाएगा। ओके सो ओहो अभी तो बाद में बात करेंगे, पहले बात करते हैं कि हाउ मेनी नंबर ऑफ मक्स रिक्वायर्ड एंड व्हाट इज द साइज ऑफ मक्स। सो फर्स्ट ऑफ ऑल साइज ऑफ मक्स फॉर टैग सिलेक्शन। टैग को सिलेक्ट करना पड़ेगा, जी हाँ सिलेक्ट तो करना ही पड़ेगा, और सिलेक्ट करके कहाँ ले जाएंगे, कंपैरेटर पे लेके जाएंगे। So for tag selection, what is the size of mux? How many inputs are coming from the cache memories tag into this mux? 4. Why? You know why 4? Just because number of sets were 4. Just because number of sets were 4, एक टैग, हर एक सेट का एक टैग यहाँ पे इस मक्स पे पास आता है। So input in this mux or this mux, number of inputs are 4 always. So this number of mux or size of mux for tag selection will be equal to number of sets in cache is to 1, क्योंकि जितने सेट्स होंगे उतने इनपुट उस मक्स में जाएंगे। Let's assume I am talking about K-way set associative mapping. If I am talking about K-way set associative mapping, आप बता दीजिए कि if we are having K-way set associative mapping, then how many number of mux required for tag selection? जल्दी से बताओ कितने हैं, आपको पता चलेगा क्या? देख लेते हैं। Let's see. Look at this particular mux can forward only one bit of tag. I want to forward all the bits of tag. So how many mux in this particular setup required? Number of tag bits. How many mux required here? Same number of tag bits. And such kind of how many setups required? 2. क्यों? 2-way set associative. अगर एक सेट पे 4 ब्लॉक होते तो 4-way होता। So number of mux required will be equal to K, which is the associativity into tag bits. I don't think so you'll be having problem in this particular formula. I don't think so if you'll be having any problem in this particular formula. If you have, then you can ask. Number of mux required for tag selection, K into tag bits. क्यों? एक particular mux can select one tag bit. I'll have to extract complete tag. That's why tag bits mux required. Right? Tag bits number of mux required, and such kind of how many setup required of mux? So many. Why? Just because मुझे एक सेट के सारे टैग्स को एक्सट्रैक्ट करना है, that's why. Okay, now let's talk about comparators. How many number of comparators are required? Number of comparators required is equal to 2 in the previous case, is equal to K in the generalized case. 4 आपको कंपैरेटर लगेंगे या K कंपैरेटर फॉर 4-way set associative mapping. For 2-way set associative mapping 2 comparators are required. अगर मैंने यहाँ पहले नहीं लिखा है तो यहाँ लिख सकते हैं how many comparators are required in the direct mapping. Number of comparators are equal to only 1. Number of comparators in the direct mapping equal to only 1. एक ही टैग मैच करना है at a time. Here multiples. How many? K. That's why K. And last thing is what is the size of mux required? Size of comparator required is equal to tag bits. क्यों? अरे कंपैरेटर करता क्या है? कंपेयर करता है किसको? टैग को. That's why comparator size will be equal to size of tag bits. Now okay, before this, if I want to talk about hit or miss latency in K-way set associative mapping, K-way set associative cache. क्या आप फॉर्मूला लिखा सकते हो मुझे? कैन यू ओनली गिव मी द फॉर्मूला? जल्दी से बताओ. फर्स्ट ऑफ ऑल, this mux का delay, all these mux will work parallel, so mux delay, then after that comparator delay, then after that this OR gate delay. So I'll be writing mux delay for tag selection or tag extraction. After that comparator delay. क्यों चाहिए? कंपैरिजन करने के लिए. ये तो इंडियन स्टाइल की बात हो गई. कंपैरिजन, जजमेंटल थिंकिंग. फर्दर कंपैरेटर डिले के अलावा आगे की बात करते हैं. रियली सॉरी इफ आई एम हर्टिंग एनीबॉडीज सेंटिमेंट्स. एंड देन लास्ट थिंग इज व्हाट? द OR गेट डिले. Sure. Okay, so if you are fine with this, then let's go further. Let us go further and let's try to understand a fully associative mapping. मैंने यहाँ पे डायरेक्टली आपको लिख दिया है fully associative mapping का कि in the fully associative mapping main memory का address is divided only into two parts, tag and byte. Using anything, nothing you are going to a specific set or something. क्यों? जो कि सारे के सारे ब्लॉक एक ही सेट पे मैप होते हैं. I'll have to check all the tags. I'll have to compare all the tags. Multiple tags are there. This particular tag will be compared with this tag. Yes. This also will be compared. Yes. This also will be compared. Last one also compared with the tag. So only comparator required. Why? Just because I don't have to extract only specific tag कि यही tag मैच करेंगे. हमको सारे tag मैच करना है. हमको सारे tag मैच करना है. हमको सारे tag मैच करना है. Yes. So if we will have to match all the tags, then I don't require any multiplexer here. Extract all the tags one by one and then compare. That's it. Take it from here and compare it directly. And at the end, a big OR gate will be required for the saying कि it's a hit or miss. अब दोस्तों मैं एक चीज आप पे छोड़ देता हूं. आप एक काम कीजिए. You do one thing कि you calculate what is the size of comparator required here. You only tell me what is the size of comparator required here. Size of the comparator required is equal to number of tag bits. And one more thing, if you can calculate it, what will be the number of comparators. कितने comparator लगेंगे? जितने tag compare करना है. कितने टैग कंपेयर करना है? जितने की ब्लॉक है. As many as blocks we have in the cache memory. You know why? Just because for each block you'll have to compare the tag. It's too lengthy procedure and too much costly. If you have suppose 2 power 12 number of blocks in the cache, 2 power 12 comparators, which is too hard to implement buddy. बहुत टफ हो जाएगा, बहुत ज्यादा टफ. Why? Just because costly रे बाबा. पैसा लगता है. पैसा ज्यादा लगता है. Very simple. Understanding. So I am writing what is the number of comparators required. Number of comparators is equal to number of blocks in the cache memory. Number of block in the cache memory. And what is the size of comparator? Which is equal to, बोलो रे बाबा बोलो, tag bits. फाइन. चलिए तो इसके बेसिस पे एक क्वेश्चन जल्दी से सॉल्व कर लेते हैं, फिर आगे की चीजें देखेंगे हम. बट बिफोर आई विल सॉल्व दिस पर्टिकुलर क्वेश्चन, आई वुड लाइक टू टेल यू दैट वी आर रनिंग courses, 4 courses on this particular channel. If you haven't subscribed this, subscribe the channel. Morning 8:30 a.m. we are having computer network, then TOC 4:30 p.m. my class is shifted to 5:30 p.m. and 12 p.m. we are having classes for discrete math. So these 4 subjects as of now running. After my COA will be over, then I will bring you a data structure course also here on the same channel. So once these courses will be over, we will be bringing you more courses on the same channel. So you need to do one thing, you need to come live here, watch the lectures live, learn live, interact and learn more. If you want to learn more, then you can go for Unacademy Plus subscription. Use the code VDEEP10 and you will be able to get 10% cut discount. If you haven't liked the channel, like the channel, subscribe the channel. Plus, if you want to join our Facebook family, go to this particular GATE Aspirants page. In the Facebook GATE Aspirants page, there we have so many members connected with us, and you will be connected with us on that particular GATE Aspirant channel. If you want if you want to prepare for GATE through free lectures like these, then the only thing I can tell you is we will complete the courses, but there is no any pre-planned structure for the courses, that when a course will finish and when other course will be coming or something. This is the channel for providing you the free quality education, dear. So we don't plan much, we don't structure the YouTube lectures much, just because our structured lectures, well planned lectures are on Unacademy Plus. So if you want that guarantee ki we will cover all the courses up to this much time, then revision also, then practice also, and GATE PYQ and every single thing, you need to come on Unacademy Plus. Otherwise, if you are learning for free, definitely we are providing the free quality education here, but there is no any time foundation that when the courses will be finishing and what is the time limit when I am going to complete this course or any course or other thing. Okay, so if you want, you can learn everything from the free sources, but the only thing is put more efforts, zero money, and you can get the best rank. Put less efforts, put more money, leave everything on us, and then hence you can get better rank. So if you are having enough time, more than enough time for your preparation, you can go for free education. We are providing you every single content which which is required for your GATE preparation. Okay, fine. So one more thing which I wanted to tell you before I'll solve the question. This is the Unacademy GATE CS channel of the Telegram, and why it is required, subscribe that channel so that you will be able to get the current PDF जो मैं आज पढ़ाऊंगा आपको, all those PDFs will be available over there. Till now whatever I taught, all those PDFs are available on this particular channel, so you can go and get all these annotated PDF on this particular channel, plus some more announcement and more news you can get from there, and it's very simple to subscribe it. बहुत आसान है भैया. And if your friends are looking for GATE preparation in other domain, we are having Creatrix for EC Electrical IM, we have mechanical channel, civil channel, the current channel, this one, then we have electrical junction in the Telugu language also, we have PYQ question channel separately, and there are some other SSC, JE and other channels also. So you can recommend all these channels to your friends. Now let's go back and solve this particular question. What it says, तो मुझे एक पेज ऐड करना पड़ेगा. Consider two cache organizations. The first one is 32 kilobyte two-way set associative. Okay, so two organizations are given. First one is 32 kilobyte, so cache का size is equal to 32 kilobyte. Okay, and then so this is the cache size. Let me write it down. Then that is two-way set associative. Then further with block size 32 bytes. So block size is equal to 32 bytes, which I have written here. Further, the second one is of the same size but direct map. तो दूसरा आपका जो organization है, the cache size is exactly same 32 kilobyte, but it is direct mapped cache. It is a direct mapped cache. देखिए जब मैं क्वेश्चन सॉल्व करता हूं ना, ऐसे ही क्वेश्चन सॉल्व करता हूं अगर कोई नया क्वेश्चन मेरे सामने आता है. अब आपको मैं अपने बारे में क्यों बता रहा हूं? जस्ट बिकॉज आई हैव क्रैक्ड GATE multiple times, 5 times under 500 rank, 19 was my highest in my final year itself. If you are hearing this particular thing first time, yes. And in the third year, 682 masters from IISc, multiple times gate I have written, so I can tell you exactly that how I solve the question, so that you can also follow the same approach. Whatever the information given in the question, like in the textual form, if you will read, write down every single thing like this, so that everything will be clear at the end. आपको क्लियर सारी इंफॉर्मेशन नजरों के सामने दिखेगी, एक क्लिक पे ऐसे हैशिंग होगी फटाक से. अदरवाइज यू विल हैव टू गो फॉर लीनियर सर्च कि कहां लिखा था यार, ब्लॉक साइज कहां रह गया. एंड ऑन द स्क्रीन आई कैन राइट डाउन लाइक दिस, अंडरलाइन कर सकता हूं, वहां पे एग्जाम में थोड़ी कर पाओगे आप. Right, so write down the details which are given in the question. Very important for such kind of big questions which are having 8 lines, 10 lines, 15 lines. Remember this particular thing. Remember this particular thing further. Direct mapped cache and same block size. Same block size, 32 bits. 32 bytes. Fine. Okay, let's try to read further. The second one is same. Okay, the size of an address is 32 bits in both the cases. So main memory ka address here also 32 bits and there also 32 bits. Main memory address size. Main memory address size is 32 bits in both the places. Here also and here also. Further, a 2 to 1 multiplexer has a latency 0.6. Then while a k-bit comparator has latency k by 10. Fine. The hit latency of a set of associative organization is this one and direct mapped is this one. First of all, for hit latency of any mapping, I will require how many number of bits are there in tag. क्यों? Just because I will require this for mux also, I will require the same thing for comparator also. तो मुझे सबसे पहले tag bit निकालनी पड़ेगी दोनों organization में. चलिए निकालते हैं, कैसे होगा? Let's do that quickly. So here I'll be having this. And here I'll be having this. Fine. Okay, so tag bits, how many tag bits will be having here in the two-way set associative? Middle field is set offset and here will be byte offset. If you will solve this question by regular method or somehow in the shortcut method, all these 32 bits will be divided into what byte offset block size is this? 5. Total 32 kilobytes. So this will be 15 minus 5 minus 1 for this one. So it will be 9. Remaining how many bits? 14 gone here. So 18 bits will be remaining for tag. And here, right side, the direct mapped cache, here will be the tag and set offset, no set offset. Here should be block offset. So block and byte. In this particular case, the 32-bit address will be divided into how many bits? This is 5 same to same, just because block size same. Here you will be having 10. Why? Just because number of blocks will become 2 power 10 and here 17 bits. Further, let's see further what is given. The hit latency time will be how much? आप पहले इधर बात करते हैं. For this one, set associative mapping. Let's see set associative mapping. What is the hit latency time? Mux delay for tag selection. Mux delay for tag selection. For tag selection, what is the size of mux required? Number of sets in the cache is to 1. यहाँ कितने number of sets हो सकते हैं? 2 power 9. 2 power 9 is to 1 का mux लगेगा. Do we have 2 power 9 is to 1 का mux given in the question? No. Ignore. Make it 0. So here the mux for tag selection is 0. Next is comparator delay. Comparator will be of how many bits? 18 bits comparator. Hence comparator delay will be 18 by 10. ऐसा क्यों लिखा मैंने 18 by 10? Given in the question, I will give you the detail also. ये देखिए k-bit comparator. While a k-bit comparator has a latency k by 10, so here 18-bit comparator required. That's why I type 18 by 10 nanosecond plus 0.6. ये 0.6 क्यों आया? Just now I told you. Just now I told you. ये देखो, OR gate can be implemented using 2 to 1 mux. Yes, 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 yes. Okay, so 2 to 1 mux here given. Yes, and that is having 0.6 nanosecond. That's why this total is 1.8 plus 0.6, 2 power 4 nanosecond. 2.4 nanosecond is the answer of the first question. Second thing, H2. In the H2, if multiplexer is not given of 2 power 10 is to 1, 2 power 10 is to 1 क्यों लगेगा? अरे बहुत पीछे जाना पड़ेगा रे बाबा. ये देखो, mux delay for tag selection. How many multiplexers are required for tag selection? Number of blocks in cache is to 1. कितने number of blocks मिलेंगे? Number of blocks are 2 power 10. 2 power 10 is to 1 का mux नहीं given है. नको. So make it 0, only comparator delay after that, and that will be 17 by 10. Why 17? Just because 17 bits are there for the tag. Okay, so it will be just 1.7 nanoseconds. अब आपका एक क्वेश्चन आएगा, सर हम 2:1 मक्स की हेल्प से 2 power 10 is to 1 or 2 power 9 is to 1 mux implement कर सकता? Yes, you can do it. Yes, you can do it. I am telling you, you can implement 2 is to 1. You can implement 2 power 9 is to 1. 2 power 9 is to 1 or 2 power 10 is to 1 mux using 2 is to 1 mux. Yes, but number of levels will be required more. Yes, in that case, so much delay required, and those were not given in the options. इसलिए हमने ऐसा किया. Okay, so I'll repeat once again. Based on the given information, I have calculated tag, middle field index, and byte offset in both the mappings. This was the two-way set associative mapping. This was the direct mapping. Now we know कि in two-way set associative mapping, hit latency time is the mux delay for tag selection. Mux delay will be how much? We don't know, just because mux is not given of that size. कितने size का mux लगता है? 2 power 9 is to 1. 2 power 9 is to 1 का mux लगता है. Then after that, block here 2 power 10. That's why 2 power 10 is to 1 का mux यहाँ लगेगा, which is not given. So hence mux delay for tag selection I have made 0 in both the cases. Similarly, next is comparator delay. Here comparator will be of 18-bit comparator. Why? Just because tag compare करना होता है और tag is 18 bits. That's why. Further, this 17-bit का tag है तो 17 by 10, and here extra 0.6 nanosecond required. You know why? Just because here an OR gate is required, and that can be implemented using 2:1 mux. That's why. So add this first question 2.4 nanosecond, second one 1.7 nanosecond. If you want the PDF of this particular lecture or other previous lectures, then join this channel Unacademy Gate CS. After the class, within 10 minutes, I will drop my PDF of this, and other lectures are already there on that particular channel on Telegram, Unacademy Gate CS. If you want to learn more about the courses in more detail, the only thing is this Unacademy Plus. You can join using the code VDEEP10. If you join this using the code, you will be getting 10% cut discount, plus you will be getting other benefits like my personal guidance. और वो guidance क्या help करेगा? अरे I have given the exam more than 6 times. Yes, 7 times total I have given the exam. 5 times I got the rank under 500. And above 500, one rank was 682, which was in my 5th semester, 3rd year. So if I have that experience, rich experience in gate teaching, then you can take benefit out of it using the code VDEEP10. Take the subscription. Tomorrow, yes, tomorrow onwards, we are having a new batch launching. Yes, tomorrow onwards, the class is going to start, buddy. Class is going to start 9 a.m. Tomorrow onwards, the new batch is going to start. If you want to learn best, you need to join this. You need to join this Unacademy Plus. Join it, and I will teach you with utmost most clarity every single topic of the courses. Okay, so thank you so much, everybody. The person is asking what is the difference between computer organization for CS and electronics. For electronics, dear sir, electronics के लिए हमारे पास बहुत कम सिलेबस है जिसको हम इतने डिटेल में नहीं पढ़ेंगे, रिक्वायर्ड नहीं है. So if you want to learn for electronics on the electronics channel, I will bring this particular course once again only for you, exclusively for you. So you can wait, and or you can join Creatrix channel over there. I am already having computer organization recorded for the EAC purpose. If you are aiming for engineering services exam, I am already having Creatrix channel. On that Creatrix channel I am already having my course recorded for engineering services exam, तो आप वहां जाके access कर सकते हो. Okay, so till tomorrow again we will meet tomorrow. Tomorrow's topic of discussion will be cash block replacement. क्या रिप्लेसमेंट होता है, कब रिप्लेसमेंट की जरूरत है, when the policy will be required for replacement, when not required, and there are so many questions based on that replacement. All these things we are going to discuss tomorrow, so stay tuned. Tomorrow 5:30 p.m. I am going to start the same thing, cash mapping and its related topics. So tomorrow again we will meet. Till then, see you and focus on learning. Happy learning. सीखते रहें, सीखेंगे तो ज्यादा दिन तक याद रहेगा. सिर्फ रटेंगे या समझेंगे या पढ़ाई करेंगे, सिर्फ 2 दिन तक याद रह पाओगे. Okay, so happy learning. Enjoy the rest of the evening in learning. See you. Good night.